Hi, this is Faris Hilmi. We continue our lesson today with lesson number 2, which is daylighting. But yes, I want to remind you that this is the subject of environmental science 2. We shall learn about light. Okay, there are two types of light that we already know, which is natural and artificial. Under natural light, we have two types of light, which is called daylight and sunlight. So, daylight and sunlight, there are a lot of difference, although these two are coming from the same source, which is the sun. Daylight is all direct and indirect light, defined as being the volume of natural light that enters a building to provide satisfactory illumination of internal accommodation between sunrise and sunset. It is also scattered sunlight that is diffused by the atmosphere and cloud. However, sunlight is refers to direct sunshine. With this diagram, we can see that the reflections of light or refractions of lights are actually called daylight. You can see example of refractions coming from the skylight, which is cloud, and also reflections from the buildings or other external material that reflected and then enter into a building. These refracted and reflected light are the daylight. So there are some factors that influence daylight. There are four types of factors. Number one, sun path. Number two, sky condition. Number three, season. And number four, solar elevation angle. Sun path. The sun path is varies across the world. The 2D that represents the annual changes in the path of the sun through the sky. It can be used to read the solar azimuth and solar altitude for a given location at any time of the day and month. This diagram are from the point view of the sky looking down at the ground. You can use this sun path diagram to superimpose it on a map or a plan so you can study the path across the time. Have you seen this sun path chart before? If you've seen this before, it means you already done some studies. If you haven't, welcome. This sun path chart is actually just an example to show you how the sun falls down to the earth and then it creates shadow after it hits the building. So each country have different sun path. How to apply this sun path diagram? The application is actually to determine the position of the sun based on the solar azimuth and solar altitude angle throughout the year. To determine the solar geometry that will be used to elevate, number 1, factor of heat gain used to determine a building's radiation need. It also, number 2, shading used to evaluate a building's need for shading. And number 3, the potential of daylight penetration used to evaluate the availability of daylight. It is also used to identify the solar radiation impact on site and building throughout the year. So how should we read the SUNPATH diagram? This gives the position of the sun, fully defined as azimuth and altitude. This is just an example of a diagram that shows here altitude of 30 degree with azimuth of 62 degree. So how should we find the position? What we see here is the outer ring here is the azimuth, which is, it shows here 62, roughly this area. And then where do we find the angle of altitude of 30 degree? It is here. So with that information, we can find that this is the position of what we just discussed. Altitude of 30 degree and azimuth of 62 degree. With this, we haven't done yet because what we need to know is the chart of the sun path. This is the diagram angle showing the time of the year that the sun is moving. From the top here is June, and it moves towards the July, and then August is here, and then it goes to September, October, November, and December. And on this side, starting from the January, February, March, April, May, and June, and goes to the other side. So that's how the sun moves on the certain area, which is this position and this height. Okay? So number 2 factor of daylight is sky condition. There are a few types of sky condition, which is sunny sky, any sky condition where the sun happens to shine through the clouds. If there are any, this can be combined with any of the following 3 conditions. Number 1, clear sky. This sky has less than 30% of cloud coverage or none. It is likely to be combined with the sun. Number 2, partly cloudy sky. This sky has between 30% to 70% cloud coverage. It can be combined with sun in some cases. Number 3, cloudy sky. This sky has more than 70% cloud cover. It normally excludes the sun. And number 4, overcast sky. The sky has been completely closed, cloud cover 100%, and it is obviously it cannot combine with the sun in a meaningful way. This is the sky condition that are applied in daylight factor calculation. So this is the picture of example of clear sky, which means it is 30 up to 30% of cloud. This is number 2, partly cloudy. You still have the sun. The cloud will be covered between 30% to 70%. This is number 3, the cloudy condition. The sky is actually at 70 to 100% cloudy, and sometimes the sun is not included, only daylight. And lastly is the overcast. This is 100% cloudy sky. There is no sunlight available during this time. Next, number 3. Number 3 of the daylight factor, which is season. In some country, they are having 4 types of season, which is spring, summer, autumn, and winter. These seasons, how does it happen, and how it is actually affected the daylight? Each season has different kind of light intensity, especially the sunlight, but they also affected a lot with the daylight. For example, autumn and winter have more cloudy sky. However, when it is winter where there is a lot of snow, the reflections of light scatter bigger and higher intensity compared to the autumn season. Alright, so how does these seasons happen during different time? So what we need to know is this, where you start with equinox on the March. When March equinox until June solstice, this is the time where you can see spring season. And between June solstice to September equinox, the weather would be summer. Okay, what I'm talking here is these seasons are actually apply to the northern hemisphere. Let's move on. September equinox to the December solstice, the northern hemisphere will experience autumn. And the next one, when the December solstice until March equinox, the northern hemisphere will experience winter. These northern hemisphere um, have experienced this will have different weather to the compared to the southern hemisphere. If, for example, like now it is already November, it is about the end of an autumn. So during this time, the southern hemisphere will be experiencing opposite of the autumn, which is spring. So when the northern hemisphere start to experience winter, the southern hemisphere will experience summer. It is because the position of the Earth axis is a little bit tilted. That's why we are experiencing different kind of seasons throughout the year between northern and southern hemisphere. They always have different season. Okay, let's move on. Number 4, the factor for the daylight, which is the solar elevation angle. The definition: the altitude of sun, where angular height of the sun in the sky is measured between the horizon and the center of the sun's disk. It is also known as altitude angle. The height or distance from the surface to the sun had influence on illuminance of daylight on the ground. So this is the example of the sun elevation angle. The stick here is also known as the length of gnomon. And then what we need to know is the length of the shadow. The length and the length of this gnomon, and then the angle is the point where you get the angle of the sun. For example, here it is shown to be 26.56 degree. So with this, actually is quite shallow, and then it is also will give a very different kind of experience to human behavior. What will happen when the solar elevation angle is very low? You will get glare. Glare is shine with a strong or dazzling light from the sun or artificial light. This glare will actually a lot of impact to the human behavior and human activity. The effects of glare is actually visual discomfort, unable to carry out tasks, and also inconsistent high volume of brightness. With this, will become actually very hard for human to do work, to 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 see what's happening in front of them, and then also it is dangerous if you are actually working on certain things. All right, so let's conclude the one that we already learned today, the differences between daylight and sunlight. Daylight is actually provide brightness for human comfort. Reflections of sunlight, not all waves are reflected, which is actually have its own beneficial. Sunlight have certain energy, which is heat. This actually good for certain time, where if you, for example, you need solar panel. So the heat of the sunlight will actually convert it into electric energy. And then sunlight also contain waves. They are infrared, ultraviolet. These two waves are actually invisible waves. However, sunlight also have visible waves, which is colors that you can see in rainbows. And then sunlight also causes glare at certain time of angle at any time. You know, we already talked about it just now. Alright, so what we already learned today is only about daylight and sunlight. Later in the next lesson, we shall learn how to use these daylight and sunlight in buildings. So that's all for today. Thank you so much. Bye.